So we want to look at this particular question under linear operators. And as I said earlier on, when you have linear differential operators with variable coefficient, the keyword is what? Variable coefficient. Then these linear operators will not commute. The commutative property of multiplication will not hold. So we have two operators here, m and then l, and then we have the function u. We want to show that operating L on M is not the same as operating M on L. So first, we are going to find our MU. So we have MU, that is operating M on the function U. Our M is what? Y the X minus X the Y. So operating it on U, we are going to just add our U to it, and then we are done. And then we find our LU, operating L on the function U. So where is L? So this is L. So we have X del U del X plus del U del Y. So from these two operators, you can see that we are having variable coefficients. So we want to verify to see if these two operators will commute or not. So we are first going to find MU, operating the operator L on what? MU. So we are starting with that. So the operator L is defined as what? X del X plus del Y. So this is what the operator L operating on MU. So this is MU. We have Y del U del X minus X del U del Y. This is what we want to look at. So once we have this, we are just going to apply the distributive property. This is going to multiply this. This is going to multiply that. We have X del X. So we have Y del U del X minus X del U del Y. Then we come for this, so we have plus del Y. So we have Y del U del X minus X del U del Y. Now looking at this, don't say this is direct multiplication, please. It's not. We are not going to multiply. We are not going to multiply. This means that we are going to differentiate what is in the bracket here with respect to x. We are going to differentiate what is in the bracket here with respect to y. It is not direct multiplication, please. So we are going to differentiate each of these functions in the bracket with respect to x first. Then once we are done with this bracket, we move on to the second bracket. So let's start with this. So we can bring x out. Now we are going to differentiate y del u del x with respect to x. We are going to do what? Differentiate the function y del u del y with respect to x. So we are going to treat this as a product rule. We have del x. We have y del u del x. So this means we are going to differentiate these functions with respect to x. So we are going to treat it as a product rule. And with the product rule, we learn that we keep the first function, we differentiate the second function, plus we differentiate the first function, we keep the second function. So we are going to keep the first function. The first function is y. We keep it. Then we differentiate del u del x with respect to x. And that's going to give us what? Del square u del x squared. I guess you are following. Then we move on to plus. We are going to keep the second function, del u del x. We differentiate y with respect to x. So when we differentiate y with respect to x, y is treated as a constant. And whenever we differentiate a constant, we get what? 0. So we have multiplied by 0. So at the end, we are going to have y del square u del x squared. This times this will give us 0. So at the end, we are getting what? Y del square u the x squared for this. So we have y the square u the x squared. Then we move on to this particular one. So we are going to differentiate this function with respect to x. So we have del x, we have x del u del y. We are also going to treat this as a product rule. We keep the first function, we differentiate this, we keep this, we differentiate that. So we are going to keep the first function, which is x. Then we differentiate del u del y with respect to x. And that's going to give us what? Del square u del x del y. Then we have plus. So with the first one, we kept x. So with the second, we are going to keep del u del y. Then we differentiate x with respect to x. So we have del x, we are differentiating x with respect to x. And that's going to give us 1. So we have multiplied by 1. So at the end, we are going to get x, the square u, the x, the y, plus what? Del u, del y. So this is giving us that. So we have minus x, the squared u, the x, the y. Then we have minus the u, the y. So we are done with the first bracket. Let's look at the second bracket. So we have plus. We are differentiating this function with respect to what? Y. So we have del y, and then we are differentiating y del u del x. So we're also going to treat this as a product rule. We keep the first function, which is y. We differentiate del u del x with respect to y. And that is going to give us del square u del x del y. Then we have plus. We kept y, right? So we are going to keep del u del x, and then we differentiate y with respect to y. That is going to give us 1. So the first one is going to give us y the square u the x the y plus the u the x. Then we look at the last one. We are going to differentiate the last one, which is x del u del y. So we are also going to treat this as a product rule. So we keep x, we differentiate this with respect to y. We are going to get the square u del y squared. Then we have plus. We keep del u del y. We differentiate x with respect to y. So we have del y. We are differentiating this with respect to y. So x is treated as a constant. And whenever we differentiate a constant, we get what? 0. So this is multiplied by 0. So at the end, we are going to have x, the square u, the y squared. This is giving us what? 0. So the last term is what? X. So we have minus x, the square u, the y squared. Very, very interesting. Let's continue from the top. So from here, let's expand the brackets by multiplying through by what? X. So we have x times y, the square u, the x squared. We are going to get xy. So we have xy, the squared u, the what? X squared. Then we have minus. This will give us x squared. So we have minus x squared, the square u, the x, the y. Then we have x, and this will give us x, the u, the what? Y. Then we add this. So we have plus y, the square u, the x, the y, plus the u, the x, minus x, the u, the y squared. X, the u, the y squared. So once we have the, we are just going to group like terms. Okay, we have the x, the y, the x, the y. We can group that like terms. So let's write this first. We have x, y, the square u, the x squared. Now let's bring this. Okay, let's add this one. So we have minus x, the u, the y, minus x, the square u, the y squared. 1, 2, 3, 4, 5, 6, and we have 3. So we are done with this. And then we've added this as well. We have also added this as well. So we are left with this. Okay, let's add this plus the u, the x. Then we add this and that. So with this, we have the square u, the x, the y, the square u, the x, the y. So we can factorize it out. So we can have plus y minus x squared. Then we have the square u, the x, the y. Is for LMU. Now once we are done, we are going to move on to MLU. MLU, operating M on LU. So M, where is our operator? Our operator is what? Y the x. So we have Y the x minus x the y. Operating on LU. Where is LU? So this is LU. So we have x del u, the x plus del u, the y. So once we have this, we apply the distributive property. We are going to have y del x, and then we have x del u, the x plus del u, the y. Then we have minus x del y, taking the second bracket x del u, the x plus del u, the y. Good. So we are going to apply the same concept here. This is not a mere multiplication, but we are differentiating what is in the bracket here with respect to x. We are differentiating what is in the bracket here with respect to y. So the y here is just a variable. We are going to bring it out. Then we are differentiating x del u del x with respect to x. So we are going to apply the same concept. We keep x. When we differentiate the u del x, we are going to get the square u, the x squared. Then we keep, so we have plus, we keep the u, the x, we differentiate x with respect to x. When we differentiate x with respect to x, we are getting 1. So this is the same as that. Then we move on to this function. We are differentiating the u, the y with respect to what? X. We are differentiating the u, the y with respect to what? X. And this is going to give us what? The square u, the x, the y. Good. So we are going to have the square u, the x, the y. So we are done with the first bracket. Let's look at this. So we have minus the s is also a constant. We can bring it out. And then we differentiate what is in the bracket with respect to y. So we are going to treat this as a product rule as well. We keep the first function, which is x. We differentiate the u, the x with respect to y. And that's going to give us the square u, the x, the y. Then we have plus. We kept x, so we are going to keep the u, the x. We differentiate x with respect to y. And that's going to give us what? 0. So 0 times the whole of this will give us what? 0. So we can clean it. Good. Then we move on to the last one. So we have plus. We are differentiating this with respect to y. And that's going to give us the square u, the y squared. Very, very easy and then simple. So we are just going to expand the bracket, y times this will give us xy. Then we have the square u, the s squared. Then we have plus y, the u, the x. Then we have plus y, the square u, the x, the y. Then we are also going to expand this bracket as well. Minus x times x will give us minus s squared, the square u, the x, the y, minus this times this will give us x, the square u, the y squared. So for me, let's see if we can group some like terms, okay? So we have x, y, the square u, the s squared. We have x, y, the square u, the s squared. Then we have plus y, the u, the x. Now we have the x, the x, the x, the x. We have the square u as well, and then the square u. So we can factorize y. This is y minus s squared. Then we pick one of the square u, the x, the y. Then we add our last term, x, the square u, the y squared. So once we are done, we are going to compare them to see if the terms are the same. So this is MLU. This is MLU, and this one is what? LMU. So let's compare the terms to see if they are the same. So the first one we have x, y, the square u, the s squared. Okay, the first one is okay. The second one, they are different. Where is it? They are different. Even this one is okay, but this one is different. S squared, the square u, the y squared. So you can see that they are not the same. Some of the terms are the same, others are not the same. So you can say that this is not equal to that. So finally, we can say that MLU is not equal to what? LMU. Very, very easy and then simple. So that is why we are saying that when you have linear differential operators with variable coefficients, these linear operators will not commute. The commutative property will not hold for them. So operating M on LU will not be the same as operating L on MU. This brings us to the end of today's lesson. See you tomorrow. Bye bye.